All right, so this example here, if it's absolute value, right? Okay, so you got absolute value of x minus 2. So this does match up to, right off the bat, with what our rule said yesterday, which said if the absolute value of some type of expression was equal to, we were using C, okay, but we can actually extend that and say it can still be equal to another expression. So an absolute value of an expression is equal to expression, as long as you've got the absolute value all by itself. And that's what we've got right here, correct? Okay. Then you can take the absolute value expression, which is this yellow part, and set it equal to, let's just call this expression 2 here. You can set it equal to expression 2, and then you got the or, and then you take expression, which is the absolute value part again, and set it equal to the opposite of expression 2. Okay, so that's what we're going to do here. We've got an isolate, so I'm going to say x minus 2 is equal to 4x plus 7. Okay, and then I'm going to write or, and I'm going to say x minus 2 is equal to, now I've got to take the opposite of this expression. So it's a quantity, right? It's multiple things. So you can write it this way. I think it's the safest way to write it. And that should tell me that that negative actually needs to be distributed to the 4x and to the 7. The number one error people make is they just make the 4 negative and they leave the 7 positive, and that becomes a problem. So now we just solve those two equations. So I'm just going to focus on this one here. I'm going to move the x over. So it's going to be negative 2 is equal to 3x plus 7. Then I'll subtract 7 from the negative 2. Gives me negative 9 is equal to 3x. Divide by 3. I get negative 3 is equal to my x. I don't know why I put a comma. Negative 3 is equal to x. So that's one solution, right? Coming over here, I'm going to do then the same kind of approach. I'm going to, in this case, I think I'm going to add the 4x. Add 4x. It's going to give me 5x minus 2 is equal to negative 7. I'm going to add 2 to both sides. And then I'm going to divide both sides by 5. In this situation, I got integers as solutions. Okay. One thing I want to pay attention to is if I take these answers, and this is something to always think about. We didn't spend a whole lot of time talking about this yesterday, but when I get answers for my absolute value, I want to check them. I always want to check them. Okay. Because think about this. If let's plug negative 3 in here. If I plug negative 3 minus 2, what's negative 3 minus 2 give you? If you borrow $3 from somebody, borrow 2 more from them, how much do you owe? 5. So that's negative 5, right? Okay. I'm just going to put the absolute value bars around now. Come over here now to this side. And I have 4 times negative 3, which is negative 12, plus 7. Okay. Well, negative 12 plus 7 gives me negative 5, right? What's the absolute value of negative 5? 5. So this really says 5 equals negative 5 when I use x to be negative 3. Is that a true statement? No. So that's actually, and even though it shows up, that's really not a solution. If I try -1 as my answer, what's -1 minus 2? Is that -3? So on the right-hand side, I'm going to get 4 times -1, which is -4, plus 7. Is -4 plus 7, is that 3? Now the question is, what's the absolute value of -3? It is 3. So then you would have 3 equals 3, right? And that is a solution. So this is a case where it doesn't happen all the time, but there are some times where you get solutions that do not work. And that's why I think, guys, it's a pain in the butt and it's time consuming to do all this work by hand and then go back and check by hand. So my hope is that we are maybe developing some proficiency in actually using Desmos to help out with that. So remember, with Desmos, what we can do, we can type in the absolute value of what we started with, which was x minus 2. So I type that in first, type in the left-hand side, and then type in the right-hand side of 4x plus 7. And now all I'm going to do is I'm going to hit x equals, and now I can type in the solutions that I found. So one solution was -3, and you see how then it gives me 2 different responses, 5 and -5. Okay, and what we're looking for is for those 2 things to be identical, right? Because this was an equation where these 2 things are identical. So that would tell me -3 doesn't work. I can type in -1 though, and that does tell me, because the 3's are the same now, -1 is the solution. So that's a lot quicker to check that way. In regards to your question about the answer then, that's kind of what I'm questioning. Now I accidentally closed out the question I was on. So when I open this back up, I doubt it's going to go back to that question or that version. We'll see. Yeah, it's not. I mean, I'll get to it, but it's going to take a while. But here's an example. This would have done the same thing. This would have given an answer, 2 answers. One of them would work, one of them would not work. Okay, and that's why it's showing that I have -2. So my question would be, maybe it wasn't really this issue here that you were having with how you type your answers, and maybe it was because we were typing 2 of the answers in. Does that make sense? If it does ask, so like some of these, like let's see if I can get to one like these. Okay, so let's cut this one out because same instructions, type an integer or a fraction as needed. And basically all that means is don't type decimals. Okay, if you go through the work and fractions show up, do not go any further with your calculator or anything. Just leave it as the fraction that you get. Okay. So in this one, what we're going to do is this has to be divided by 2 first. So we'll have 3x minus 11 is equal to 7. And now that matches our rule for absolute value. So we could take the absolute value of 3x minus 11, take the absolute value bars off, and set it equal to 7. Or we go 3x minus 11 and set it equal to -7. We're going to add 11 to both sides. 3x is equal to 18. And then I'll divide by 3. And x is 6. We'll talk about that in a minute. So then we're going to add 11 here. Add 11 there. So I get 3x is equal to 4. And now I have x is equal to 4/3. So that's the situation then that I don't want to grab my calculator because my calculator is going to tell me that that's 1.33 repeating. And if I round that, 1.3, 1.33, 1.333, or whatever, it will not produce this as a true statement. It'll be like 13.9 equals 14, or 13.99 equals 14, or 14.01 equals 14. And those would be false. But if I use the exact fraction, then it's still going to be 14 equals 14. I would still check this. So we had 2 times absolute value of x, 3x minus 11. And because the right-hand side was 4, I mean, we can put 14 in here, but if I go x was equal to, what was the first one we figured it out was 6. So x was 6, does it give me 14 and 14? Okay. And the other one wasn't negative 4/3, positive 4/3. Come on. And then we see we get the 14 again. So that shows us that both are answers. So then what we're going to do when we type them in, ask you for separate them by comma, so 6, and then 4/3. Or you go 4/3, comma 6. You'll accept both orders. Let's see here. This was a question that kept getting flagged on 1.5. So I'll talk about it. So it says solve the compound inequality. So there's 2 ways we can look at this. If it's presented this way, my suggestion, leave it this way and do the work this way. But you could rewrite this as -2 is less than or equal to 2x minus 8. So basically looking at just that part right there. Does that make sense? Okay. Then we can put the word and in between. And then we're going to write 2x minus 8 is less than or equal to 4, which is exactly that thing right there. Okay. You can solve these individually, or you can solve them at the same time. So let's kind of just do a quick run through of the first step that maybe you would do here in this red one. What would you do in that red one? Okay. Are there any like terms on this side though? No. Okay. So I think what you're saying combine like there. Would you add 8 to both sides? Okay. So that's what we do first in the red one. What would you do first in the blue one? Still add 8, right? I think that would be the most logical thing to do. Okay. So that would, on the left-hand side, and you don't need to write this down, but that would give you 6 is less than or equal to 2x. Over here, give you 2x is less than or equal to 12, right? What would you do on this left-hand side now, with this one that says 6 is less than 2x, less than or equal to 2x? Divide by 2 to both sides. What would you do over here in this one? Also divide by 2. So do you see that your steps were the same? Added 8 to both first, and then divided by 2 to both first or second? Does that make sense? So traditionally, because those steps are always the same, when it's presented to you like this, most people don't rewrite it as 2 statements. They just say, oh, I'm going to add 8 here, because our goal is still to get the variable by itself. So I add 8 there, and I'll add 8 there. And that was like we were adding 8 to that blue one that I had. And then we're going to add 8 here, and that was like adding 8 to both sides of that red one we had. Does that make sense? So you're doing it all, you're doing both those small, tiny inequalities simultaneously here. So that would give me 6 is less than or equal to 2x is less than or equal to 12. And now, again, we're still trying to isolate the variable term. We've got the variable term isolated, so now it's a matter of turning that variable term into a 1x. Okay? So I'm going to divide this by 2. So I'll divide this side by 2, which would have been like dividing the red one by 2. I guess that was a blue one over there. And then dividing the red one by 2. What's 3 divided by 2? Or sorry, 6 divided by 2 is 3. Sorry. 2x divided by 2 is x. 12 divided by 2 is 6. Does that make sense? And that's how they then want you to type your answer in. If I was to graph this then, it's nice because it tells me this x, if I were to look at it just its position right now, the way we wrote it is it's the middle thing. It's between 3 and 6, right? So x represents all the numbers between 3 and 6. So if I find my number line 3 and 6, x then is all of these numbers that are in between, all of those numbers there that are in between, and because of the equality, we include 3 and we include 6. So those are all my solutions then. Okay, and I don't have to do any overlapping. Does that make sense? If you remember, when we talked about this initially, that meant that we had x values that were bigger than 3, bigger than or equal to 3. So we would draw like that line right there. And this one here meant that we were looking at values that were for x that were less than or equal to 6. You know, we draw that. And then we say, okay, well, it said and, so it was the overlap, which is the red, right? But now we don't have to do that because the way we went through the problem, it automatically set my answer up to tell me just highlight the answers between 3 and 6. Does that kind of make sense? Okay. On those two, so 1.5 and 1.6, do you guys have any specific questions that you are confused about, worried about, struggling with? Not yet? Okay. So let's do this.